So there's a good number of folks who are having problems with their high vulnerabilities that are actually extending past the prescribed time periods. So that's cool, because that's the entirety of the problem that we're trying to solve. We're going to talk about what is going on there. We're going to talk a little bit about where that comes from, because even though this is a very technical room, we know that there are going to be millions of viewers on the YouTubes over the years. And so we're going to try to make sure that people understand the technical background or the business driver for where this is coming from. This is fairly new. So a little bit about disclosure. We have individually worked with most of the major providers in the context of building out one of their static analysis tools. So we're a pretty friendly group to them. We think that's important for you to know. Also, we build a automated remediation tool. So there's our bias. We try to keep, this is very much not a sales presentation, and it's very much kind of just talking about what the industry does, but we wanted to make sure that you understood where we're coming from. Quick disclaimer, I don't think this matters as much for this slide, but do everything at your own risk, hire your lawyers, don't break stuff that isn't yours. So a little bit about us. So I'll introduce myself, and then Demetria will introduce herself. I can't actually read that, so I'm not going to. What is this? Oh, thank you. So I started as a software developer in '98. By around 2006, I was the InfoSec architect for a company that was too big to fail. Most of my really hardcore manual static, and dynamic, as well as my automated static and dynamic, was really done with Andrew here over at AppSecUSA. We used to, on a pretty daily basis, break into some of the coolest stuff that I've ever heard of. Financial networks, more than one global, more than one national bank, and obviously enough financials that we just stopped paying attention to it. A couple of years ago, I was on a project, and we ended up building out an AI. We'll go into that in a little bit of detail. I also hack for fun, a digital nomad, social dancing, photography, and this is Demetria.
Hello. So I am the COO at FuzzyLogic, but my background is in data science, and then before that, business analytics. So a lot of what I do is manage both the data and the business functionality within FuzzyLogic. The background, a lot of that fits into software product development, and then specifically fits data-related products. Just fun stuff. I like a lot of rock climbing, blues dancing, and go on adventure photography trips quite frequently. Even if I have to bring my laptop.
So at this point, I'm going to go ahead and I'm going to more or less stay here, just so the camera person knows that it'll be easier to keep a hold of me. So you're going to find a lot of times the slides are saying something and I'm talking about something slightly differently. It's because I assume that you can read while I'm talking. If that's not the case, please go ahead and lift your hands up. And I'm immediately going to start walking again. So sorry, camera person. So about mid-2000s, I'm just taken reign of a assessment for about 2,500 projects at a bank that's too big to fail. We go into the room. There's about 20 to 30 project managers. I've got my security engineer, my security project manager there. And as we're going down the project and the process that's about to take place and how we're going to need their developer resources and how we need their resources, as we get to that critical point, one of the gentlemen bursts out with an exasperated, "Why are we doing this? This is a waste of time. I don't care." And our security engineer had a polite discussion. Project manager had a polite discussion. Guy is escalating. So I cut in and I asked, "So we have a policy memo that went from the CIO. It came through your chain of command. Budget has been allocated from outside your group in order to pay for this. What more do you need in order to figure out that this is important to everybody above you and make it important to you?" Silence hits the room. And then there's one of the other project managers looks at him and says, I don't think you get it. These guys are your auditors. You're not going to get around them. You have to do what they say." And all of a sudden, everybody fell in line. But until they understood that it was inevitable, until they understood that they were wasting time fighting, they were going to waste time to prevent wasting time. They were going to try to protect their developers. And even though there appeared to be compliance at that moment, every single step of the way, they were trying to protect their developers. Oh, the architect's not available. The architect is available, but they can only answer specific questions. Let's go ahead and just guide this process. Because of the basic problem is that the business needs to manage security at a high level, and the developers are scarce. And from the developer's perspective, they need to figure out how to get the risk reduced, not just for their application, but they've already rolled over to 10 to 15 other projects over the course of their life. So they're actually often managing a portfolio of applications, as are each of those project managers, as is the entire organization. So that's what we're going to be talking about, is how to solve that problem. Next. Gotcha. So what we've seen already is there's a big push to secure the SDLC. That's good. We're seeing a big push left. That's good. But what about the existing portfolio of applications that are already in production? So it's the end of the year. It's the end of the year, and a development manager who owns, at a different company, who owns a great many number of projects, has called my manager's manager into an office. We've got about 10, 15 people at the desk, and the development manager is saying the exact same things that we have all heard a number of times. I'm going to name them, and if you've heard these things, go ahead and just raise your hand. Can we focus on the high priority items? Everybody. What about the false positives? Can we get rid of the false positives? What if we only fix the low-hanging fruit? Right, so everybody has heard all of those things. He was, of course, repeating them all to us, and our responses were probably the same thing that you did. Well, based on the risk of your application and the type of vulnerability, we believe that all of these are in the high level of concern, et cetera, et cetera, et cetera. You've had that conversation before, so I'm not going to go through the entire thing. And then he says, so what are you doing? You're just coming here and giving me a big pile of bugs. You're just giving me a big mess. And I said, well, what you have to imagine is that you're in a cave. You don't know what's around you, and the job of information security is to shine a flashlight into all the little crevices of that cave so that you can see what's there. And he replies, but there's a bear there. And He says, you're just going to leave me with the bear? And here's the reality of the current system. Yes, that's exactly what we do. We leave them in a cave with a bear, so a general guideline that says, if you see cross-site scripting, OWASP, the OWASP cheat sheet says this is how to fix it. P.S., there's like 27 different rules in the cheat sheet. They're mostly correct. Some of them are hedging so that it's easier to understand. But yeah, you should definitely try to keep all of those in mind for every single vulnerability. Oh, and by the way, you're going to fix it. We're going to tell you you fixed it wrong, and this is going to happen a few times. And it's going to go through all of your development cycles. Because of course they're immediately asking questions like, well, how do we pay for it? And every organization has a different answer to that, right? Well, how do you pay for your normal bugs? Bugs? These aren't bugs. At some organizations, they say, well, we have this bucket here. We fund through it, right? Those are a lot easier conversations for us as security people, because when they know that there's an easy path, fighting the developers turns into a much smoother conversation. So now this is a development manager. So he's actually not looking at a cave with one bear. What he's actually really looking at is a whole bunch of bears, because he owns an entire division and he owns a lot of different applications. So another theme for this for today is we think of application security. We think of a manual pen tester or going in, or a automated security analyst assessing a process, an application. That's how we compete with each other. Honestly, like if you pull back the veneer of we're all in this to make everything secure, and you ask the question, how do I keep my job? It's because I found something and that guy didn't find anything that I didn't, right? At the end of the day, we're providing that valuable information. And it might be high-level information, or it might be highly detailed information, but in some way, we're providing a bit of information that somebody isn't, right? And so the tool vendors start competing with each other to show the most vulnerabilities. And then they start trying to show the most potential vulnerabilities. And then they start trying to show things that, if you could get a really good analyst, which I actually do recognize a decent number of you in here, these are you. You get a really good analyst, they might see a hint that might unlock the world, right? That's how the tools are competing with each other, because that's how the sales cycle works, and that's how we as buyers request them. But then what happens when you bring that into an actual organization, as you start trying to actually pull out an actual business process out of that? I dare you to run an analysis tool on an entire portfolio of 1,000 or 2,000 applications. Jeff Williams was quoted yesterday in Hack News saying that there are 2,000 to 20,000 applications in an application portfolio for a major company is about right. That seems about right to me. And so if you're talking about 20,000 applications times your basic report stack, let's say it's 200, but that's unvalidated. So unvalidated, you're probably looking at 15,000, some odd. You can usually scale it down to about a quarter of that with just automated filtering, getting rid of things that you don't care. But you're still looking at a sea of vulnerabilities that are just so huge that you can't really do anything meaningful there. So it actually wasn't surprising. After the conversation with the bear, we did our annual report out, and we felt we'd done actually a really great job. We had a couple of engineers for roughly half a productive year, and in addition to bringing out the processes and procedures and all of those things that you have to do, and the buy-in and teaching and et cetera, we had managed to bring, do we have that slide? We had managed to bring, except we don't have it, we had managed to bring together a solid 20-ish applications. And we were showing a depth of understanding that into their portfolio that where we would say 500, one of their other analysis techniques would say 5. And we're like, and we can defend every one of these. We have defended them to the developers, every one of those. So they were starting to see a really important conversation around what each application was doing. And we got our applauses and we were feeling really good. And then somebody says, 20 applications, that I actually had no, he wasn't an application developer, he says, 20 applications. I don't know if that's good or bad. How many applications are there in the company? Well, there's about 1,000 in the high risk model level, at this level. Do that math. You're talking about, what is it, 20 divided by 5, 50? 500? Yeah, I don't know. She's the data scientist. That's a lot of years before you get through that portfolio. So you have this really good slice of data, and it's all important data, and it all needs to be actioned on. But to get through the whole portfolio, you're talking about an unreasonable number of years. And then remember how long it takes to actually remediate that data. So the reason I say I dare you to run a scan across the entire application portfolio and then report that back is because you'll get a response that I heard from a different manager. I'm saying we is just a general part of our lives, part of my history over the last 20 years. We were at a consulting company that was very good at giving high-level, specific, targeted advice on the architectural level. And they looked at us, the manager said, are you guys going to run another scanner? Because we already have a file cabinet full of scans that we can't touch. And then he went into legal things, talking about due diligence and due care, and if we actually know about it, and when we know about it. And then he starts talking about just how overwhelming it is for the developers. So imagine, so if you do that giant scan, there's almost no chance that whatever your project was doesn't become shelfware. I've never seen a project go to shelfware, but everybody who's talked to me about shelfware has that pattern in it. But it's a really hard conversation to have to talk your development managers out of doing that scan. It's so sexy. It's so attractive. Okay, you're in a cave, right? You've got a flashlight. There's a spider over there. Is there one up here? What about there? What about there? You want to know everything as quickly as possible, so you just kind of start shining it around so you can see something, right? And you get this idea that if you go breadth first, you'll get some information. But there's so many false positives that you wind up pulling those out. So, let's see. So vulnerability backlog. Let's go to the next one. So, okay, so back one. So that's where the remediation side came in. Because we started asking the question, what can we do to help the developers? Because at a certain point, people are going to figure out that they're vulnerable. And then they're going to have to start reallocating resources to remediating that. And that's exactly what we did. So we went off and we figured out how to remediate cross-site scripting in JSPs, and then we just started doing case studies to figure out how much it would fix. And this is and we chose the open source. We chose the GitHub open source community for that. Now, it turns out that there are huge process and procedures problems in doing something that I thought back in March when we started this process, I thought this would actually be pretty straightforward. You have a bunch of code, you can download the code, you can run the scanner, you can run the fixer, you can run the scanner, you can report the results. These are things that you can do, and because we're reporting the results not as a findings list, but as an actual pull request, like here, accept this, and this many vulnerabilities go away, we thought that it would be easy to gain acceptance. But what we've actually found is that at every step along the way, we were waved off from doing this. And so there's going to be a decent amount of conversation that we want to start having with the community, and I'm glad to see a lot of these folks here, because we weren't able to file the issue reports. I mean, we could have, but we were told in no uncertain terms, if you file these issue reports, you will piss a lot of people off. And we need to figure out exactly what that looks like. We did a little research into what responsible disclosure normally looks like. 7 days, 90 days, 45 days. Everybody bounces around in that range. But does responsible disclosure do those same rules make sense when you're giving a solution as opposed to a problem, right? Because you've just narrowed their solutions or their solution time down so much that it shouldn't be an issue. We need to have that continue to have that conversation, because as a realistic perspective, so
this was kind of our plan going in, and and it still is the general framework how we conducted the case study, but we did have some snags operationally and in terms of working with GitHub, which we worked with them on a lot of the aspects for downloading, because when you're downloading 160,000 repositories, it turns out like you need to work with them a little bit. They're not used to that kind of load. So first off, I'll kind of go into a little bit about the project. Fozzie has kind of mentioned a lot of these things at this point, but the inspiration was really that we knew we could help other people with this tool, and we wanted to have kind of proof of concept. But a big part of that too is also the sample diversity that you get there, because you have a wide variety of programmer skill that's putting code out there. You have different coding standards that are being used. You have different contribution constraints. There's a lot of, some projects have a lot of collaboration, so you have a whole bunch of contributors, and those get a lot of attention and a lot of help where they're needed. And then there's other projects that don't. And when we were evaluating these things, this makes a big difference. So kind of going into that was actually a really big reason as to why, or the value that we got out of being able to apply it to such a diverse sample. So for the goals, again, proof of concept and getting additional edge case code for our own tool, because a lot of our tool remediates most of XSS, but there are edge cases, and we wanted to have exposure to other cases to make sure that we actually have an even better tool. So improving our own side as well. And then also with the data that we get, really identifying where are the opportunities for kind of growing this type of technology? Is it in expanding it to more languages and expanding it to more vulnerabilities? Like what is actually the best way to provide the most value going forward? So with all of this, we did, for our quality control, we did use a third-party scanning service, FindSec Bugs, before and after, so we could kind of audit our results rather than just reporting, rather than just being the only source of data for that. So everything that we did was for Java, and specifically JSPs. And so why Java? And Java and .NET are consistently the highest areas of concern, and it's because of just their broad range in applications throughout the business world. When you're looking at like most financial companies are based there, most airline companies, you have major industries that are very, very highly Java-centric. So so that just means that it has to be prioritized when you have problems. And this has been reiterated in the SAM State of Application Security for like the last 2 years, and before that too, but this is the most recent. Again, it's not that the languages themselves are inherently problematic. It's that you have such a broad usage of them that if someone can take advantage of certain vulnerabilities, they can scale it a lot better, right? You can get scale. So that makes it really important to fix things. And then the next thing is why XSS. So in 2011, Denham Group actually provided a study on only 20 plus samples, so there's a bit of a sample size issue, but it's really useful to kind of look at what kinds of vulnerabilities you see, like the distribution, and by sample count, and then they provided the average fix times. But it kind of multiply that out and kind of evaluate, well, how much time does that really mean is being spent for each of these types of vulnerabilities? Because if it's a whole bunch of them and they're a super easy fix, is that better or worse than a much smaller number, but it just takes a lot longer? So if you just want to go by time spent on vulnerabilities, you're looking at, XSS is over 43% of the vulnerabilities found, and then they take over 47% of the time for remediation. So if we're going to go after one vulnerability type, we got the most bang for our buck here. So whether you're looking for, whether you're trying to reduce the number of vulnerabilities or reduce severity, you're doing pretty well if you can get rid of just the XSS. So what we did was go into GitHub for our data sources. We had the code from GitHub, and I think something to kind of note about the code from GitHub is its inherent nature. It launched in 2008. It has some people did post older code on there afterwards, but for the most part, you're looking at code that's been developed within the last 10 years, or less, mostly less. And so there has been a big push for more secure development, and so it's not necessarily representative of the legacy code that you see in larger organizations. because that hasn't undergone like the same level of scrutiny in the development process, right? So there's already going to be fewer vulnerabilities, ideally. And then for us, we were just looking at JSPs, and many of the projects are not robust enough to really require a whole bunch of JSPs, even if it's a Java repository. So there's some kind of interesting things when you're taking GitHub as a sample set. The next thing. Mm-hmm.
So for example, since 2008, there have been a big shift from JSP development over to Android development. There aren't any JSPs in Android development, so all of those projects are just going to wind up being nothing. Also, a lot of projects don't have a front end when you're dealing with a lot of the open source projects, because it turns out people don't make a lot of server software in the open source community. Like your bank runs on JSPs, but they didn't pull that from an open source project in most cases. There are some out there, and we tried to find them, but we really didn't have great success trying to find those. That's a lot of what she's talking about, right? Like most of the Apache Commons, there's no JSPs in that. So that's kind of giving you a sense of what's happening to the sample set.
When we started looking at gathering data for it, we have two major sources. We have the third-party vulnerability reports. So before, after looking at what types of vulnerabilities are there, what kind of distribution, and it identifies, exactly which each individual vulnerability. So we can kind of see within our remediation process the actual impact that we're having each time for each code suggestion, right? So, and then again afterwards, the post analysis there. And for this though, we started running against the over 160,000 GitHub repositories, and finding that projects with JSPs are actually a very small percentage of that. We kind of stopped running through the entirety of that and focused on starting to run through the 808,000 individual JSPs. So that's JSPs. So there are repositories that contain multiple JSPs. So it doesn't quite tie, but the way that GitHub search functionality works, you can't necessarily separate it the same way. And when we're doing that, we're also collecting data on the repositories themselves. So their age, how recently they've been updated, how many open issues, because we're looking at when it comes down to not only the security level that repository is at, but also how open they are to suggestions for remediation. We want to see what kind of behavioral characteristics are kind of feeding into that. So when we're going through our results, we did find that the presence of vulnerabilities was actually really bursty. You'd find one repository that had one, and then you'd find 20 to 30 in another, and then one that had 250, right? And so you have this really, it's really bursty, even though there's still a couple here and there. And when you look at that, I mean, it kind of also makes sense because there's a lot of, so repositories that had a lot of user contributors and that were more built out tended to have fewer vulnerabilities. And I mean, that kind of can be expected because you're getting more and more involvement in making sure that it is safe. And so if there were vulnerabilities before, someone has already come in to try and fix that. So community involvement in these projects is really, really important because the repositories that we found that had the most, in most cases, they were not, they either weren't being maintained very recently, or they had a very limited number of contributors, often one. So again, we also found a really high presence in test code, which, I mean, a lot of times people think the test code doesn't have to be secure, but there's people, there's people who are forking their test code and then using that test code for other things. And so that kind of multiplies. Then you have, it also means that people are in test environments that are actually simulating something that's not the actual environment if the actual environment has those security protocols, right? So, and then another big thing was the forked repositories. So a lot of the repositories that still had a lot of vulnerabilities were forked from repositories that are well maintained. And so those origin repositories had much lower vulnerability counts than many of the forks because those people are not updating, they're not rebasing, they're not getting the most recent updates from the master branch. And so they just keep those vulnerabilities going on. Mm-hmm.
So one of the two things that I'd like to make sure you take away from this. The first is we saw a ton of Struts 2 branches, Struts 2 forks, which means, so the Equifax hack was based off of a known vulnerability that was reported back in Struts 2 back in, I believe it was March of this year. So anybody who forked before that isn't getting those automated updates. And where that applies to us as defenders and generally not defenders of the open source community, but defenders of your corporate castles. A lot of us have clients that have centralized security controls. And a lot of those clients also have a process for internal forking of those same APIs. And whether it's security controls or other APIs, we've seen again and again that there's this weird thing that happens because if we detect a vulnerability in a piece of fork code, maybe they fix it, or maybe they say, hey, it's also vulnerable over there, so why don't they fix it, and then we'll bring it forward at some later theoretical rebasing. Oh, but that's probably going to be complicated. And so you actually see this same phenomenon manifesting inside of large internal organizations as well. And it's again, we're talking about open source, but every bit of this parallels to what we're seeing in major organizations as well. Please continue.
Yeah, especially they have their own frameworks built on top of standardized programs. So for things that are XSS specific, again, older repositories, they were significantly more likely to have more XSS vulnerabilities. Newer code had less, but it's still there. It still has a presence. It's not. Even though there's a lot more knowledge and there's a lot more tools to make sure it doesn't. We never have it. Things do slip through, and we found something similar for, for XSS specifically. Once we started narrowing it down to JSPs, then there's even a higher incidence of XSS because of the nature of JSPs. So, but that's not necessarily representative of programs as a whole. So when we started going into this, I don't know if you want to talk about like kind of the net impact and kind of distribution, because we found like we could get a lot of bang for a buck just taking out whole sets of test repositories or fork repositories that are all pretty much the same thing, and so you can like scale that validation afterwards a lot easier.
Yeah. So what we don't want this to become a product demo. So what we want to get everybody thinking about here is, what is that point where you have enough automated remediation that it makes sense to run this at scale, right? If it's one vulnerability out of your entire portfolio, you probably don't care that you fixed it, but because of the development costs that are involved. But if you were able to knock out 20% of your if you were able to knock out specific classes of vulnerability, is that something where it starts to make sense to run across your entire portfolio? Because the time costs start switching, and hopefully I'm not going too far into what you're about to talk about, because the time costs start switching. So imagine what happens if instead of a vulnerability report that takes about 2 years to do the remediation, you are instead running through everything, automatically creating an issue, and then automatically creating a pull request so that they can see the diffs, the actual diffs, to fix the code. And so now, either at the point when they are coming back around to do the next to do their next fix, or they have a team going through and pulling these pull fixes in, pull requests in, you're able to start moving it in that direction. So we were looking at getting about 20% of existing cross-site scripting based on the types of XSS that I've seen throughout organizations throughout the years. So a lot of the exotic stuff we just don't touch, right? Because we're all, a lot of us are static analysts here, right? The false positive to false error rates get really ugly really fast. But the tools tend to know a decent amount about a little bit. And if you scope everything down really tightly, and then you ask a couple of clear questions, you can start remediating entire sections of it. Can we open up for questions? I want to make sure that we have a little bit.
Okay, I mean, I think it is kind of important to kind of stress the responsible disclosure aspect, and especially because we went into this, a big draw was that we'd be able to discuss a lot of our findings, but then we were actually asked by GitHub not to issue not to create a lot of the issues that we were planning, which even though we had kept those at a higher level, just vulnerability counts, and then not follow up with a pull request because of review time. They thought it would be they thought it would actually create a much bigger security threat, especially when you have people, if they don't accept the pull request, then it's out there and it's not being fixed. And it's a very public nature in how issues are created and pull requests are sent. So that's all public. So we are in the process of finding ways to do this in a more private fashion and contacting them individually so that it's not publicly available.
So, and we appreciate their concerns, and some of the concerns that you mentioned were things that GitHub mentioned, and some that were mentioned by others talking about responsible disclosure. We think that this is different. We think that we think that the goal of open source is that everybody is going in and pitching in. And so this feels like a software developer going in and saying, hey, I found a fix, and here is the fix. And I feel like if I was writing that software, I would want that. But we respect that there are different views, and we decided to make it a conversation rather than just enforce our view on everybody. The world's not going to change if we take a pause to have that conversation. We do want you to send us your opinions because we did the research and we just couldn't find a great answer.
So yeah, we'd like to be able to send them in. They are requesting more of an opt-in format, and that's kind of where they want to go. That's why they have a lot of plugins you can use for us. That's what they are trying to push. So this isn't quite the structure that they would like. So.
And we do plan on publishing everything, even within the responsible disclosure community. At most, they are going to get 90 days before we publish it. So we're really likely to publish. So if you want to get in contact with us, we'd love to get you like hard data. And so, I mean, she's a data scientist. It's killing her that she can't show you numbers. And it's my baby. I really want to show it.
But just to kind of at least illustrate kind of the concept of what we are talking about for comparing remediating one vulnerability type over the entirety of a portfolio versus a more traditional approach of going into an application and just looking to remediate everything with it, be done with it, and move on to the next. When you do something like that, it's very satisfying to have your entire project cleared, and it feels good. But in the end, if you have, so if you have a lot more vulnerabilities in your portfolio and you only get a percentage of them, you can still end up with significantly more progress corporate-wide rather than just tick boxes that you can say are actually fully complete.
So here's some additional resources. If you'd like to get in on that conversation, so here's a bunch of the resources that we use. If you'd like to get into a conversation with us about how, especially responsible disclosure, and the general automated remediation movement that's starting, we're really interested in that conversation. Please send us a line, take a photo. There are going to be a lot of conversations, more conversations about remediation. There are also some existential questions. Like my perspective was that the AI was a person, and so a person doing this would have been totally normal, just faster. And that was clearly not what every person felt about it. So, it's I'm interested in those discussions. So our time is up. We're going to clear. Thank you very much.